Hello, this is the third video for section 9.8. Now we're going to do rational inequalities. To extend the ideas of test intervals to inequalities involving rational expressions, we use the fact that a rational expression can only change signs at its real root, real zeros, again, so we're still going to have to find those, and its undefined points, though. So a parabola is never undefined, so that's why we didn't have undefined points with a parabola. But with rational expressions, you can have undefined points, and those are when the denominator are equal to 0. So let's solve the following inequalities. So the first thing is we want to find our zeros, which is when x over x minus 2 is equal to 0. Go and multiply both sides of this equation by x minus 2. The x minus 2's cancel out on the left, so we get x, and 0 times anything is 0. So our zeros are 0. And now we need our undefined points. Again, that's just when the denominator equals 0. So x minus 2 equals 0, x equals 2. So those are our undefined points. So now when I do my number line, I have to put 0 on there and 2 on there. But when I do my dividing them, I try to make a different color. If you don't have a different color, maybe do a jagged line for the undefined points. Because those are the undefined points, you can never equal them, which means no matter what the inequality is, that number will have a parenthesis. Where the other number is a 0, that will depend whether the inequality is less than or equal to, or greater than versus greater than or equal to, depending whether it's a strict or loose inequality. But now that we've found our zeros and the undefined points, we still go through and find our test values. So -1, 1, and 3 are good candidates for this one. And again, plug them into the original inequality. So -1 over -1 minus 2 is 1/3. Is that greater than 0? Yes. 1 over 1 minus 2, which is -1. Is that greater than 0? No. And then 3 over 3 minus 2 is 3. Is that greater than 0? Yes. So now my answer is 2 intervals again. So I'm going to have negative infinity to 0, and then 2 to infinity. Well, infinity always has parentheses. Undefined points always have parentheses. So the only one that I have to look at the original inequality for is 0. So for 0, I go back to the original inequality. This is a strict inequality, so it is also going to be a parenthesis, and then don't forget the union symbol. Part B, 4x over x minus 6 is less than or equal to 1. So again, I'm going to find my zeros first. So that's when 4x over x minus 6 is equal to 1. Multiply both sides by x minus 6. We get 4x is equal to x minus 6. Subtract x from both sides. Get 3x equals -6. Divide by 3, divide by 3. We get x is equal to -2 for our 0. And then for our undefined points, that's when x minus 6 equals 0. So that's when x is equal to 6. So our number line is split into 3 regions again. We get -2 and 6, with the 6 being the undefined point and -2 being the 0. Now I need to go ahead and pick my test values. So -3, 0, and 7 look good. 4 times -3 all over negative 3 minus 6, which is 4/3. Is that less than or equal to 1? That's false. 4 times 0 over 0 minus 6, that is equal to negative 2/3. Oh no, sorry. 4 times 0 is 0, so that's equal to 0. Is that less than or equal to 1? True. And then we have 4 times 7 over 7 minus 6, which is equal to 28. Is that less than or equal to 1? That is false. So our answer is going to have a single interval, and that's a negative 2 to 6. The 6 is the undefined point, so that's always a parenthesis. So I just need to look at the original inequality for the negative 2. It's a loose inequality because it has an equal to sign, so it's going to be a bracket. And that is the end of section 9.8 notes.